So this is PIC Game Programming Part 10. So from this point on, it's just user interactions that need to be dealt with. So in this particular part, I'm going to handle user settings. So for the constants, because I'm handling user interactions, I'm going to define special constants for what each switch does. So on the switch on GPIO 5, it sets the level, and then the switch on GPIO 0 sets the sound. GPIO 2 sets the simultaneous number of LEDs that can be lit at one time, and GP4 is to start the game. And for the RAM variables, I'm going to add sequence max count. So in this one, the user interaction is going to be setting the level, and when you select the level, it sets the number of sequences the user has to match in order to win that level, and that goes in the sequence max count. I've also added these other two, but these won't get used until the actual game programming is done. Sequence game count, so the game can keep track of how many sequences it's up to, and sequence count, so that it can keep track of when the user is answering as well. And then everything's going to be done in one function for this particular part. I'll just do a quick reminder of the point that we got up to. So this is the loop for the actual main application, and it's like checks what the state of the application is in and calls the appropriate function. So I'm going to be handling this function today, the mode select. So this is just where it handles user setting up their settings, like turning the sound on and off, and setting the levels and starting the game. I've also uncommented this. I've put a little dummy function in for the game mode at the minute, just so that I can clear the key presses if it ever goes into game mode, so that the device can sleep. But that's just as a temporary thing. So go down to the actual function itself. Here it is. So this is just the function itself. It just keeps getting called every time it goes around the loop. Because it's just about user interactions, all it is going to be a series of checks for key presses and then taking action on what those key presses are. The first time it comes in, each of the states that I tend to go through, the first state is considered for the substate an initialization mode, so I can set up what's going to happen with this particular state, and then it can go, next time it comes in, it can go through and actually handle the state itself. So if it's in the initialization mode, it sets the next mode to be what I want it to be, which will be to go to this area here. It just sets the sub mode, and also it sets up to animate the LEDs to rotate them clockwise. So that's what that does. So that's all the initialization does. So the first time through here, the first time that we go into this mode, it just does those couple of things, and then the next time round, when it comes into the loop again, it'll go into this area here. So in the interrupts, as described previously in the previous part, any key presses that get flagged as having been pressed go into this RAM variable there, and then with the constants which I defined at the top at the start of this part, I can check to see if the level switch has been pressed, and if it has been pressed, it's just a simple matter of increasing the level, checking once it's been increased if it's gone past the maximum. So in the level RAM variable, the value can be 0 to 3, and that maps onto the actual what the user considers a level as 1 to 4. But if in the variable it's gone to 4, then that's gone over the top. So that would then need to be reset to 0. So what I do is an exclusive OR with the level variable and the value 4, and if that sets a 0 flag, that means it's a match, and if it's a match, then we clear the level, so it starts again at 0. So it will, when the user selects level, they go from 0, 1, 2, 3, and then it will wrap around to 0 again. So it takes the value of level that's just been set and puts it into the W register, and then it sets the initial value, max sequence count, which is the target number of sequence matches the user has to actually match. and it puts the level number into there. So that'll be at this point either a value from 0 up to 3. Then it adds 1, and the reason it adds 1 is then it kind of puts it into the level that the user's considering. So that'll be a value of 1 to 4. And then it multiplies the value by 2. So this rotates the bits in the RAM register to the left by 1, and if you do that, you're multiplying the binary number by 2, and then it multiplies by 2 again. So that's multiplied by 4. So if you had if you'd selected level 1, you'd now be on to a value of 4 for the actual number of sequence levels. And for level 2, it'll be 8, and then it goes up to 12 for level 3. And so you can see in the comments on the right, I've added a comment for each level saying how it's calculated up to the user has to guess 16 sequences on level 4. Then what I want to do is I want to display to the user the level they've selected on the LEDs. So this LED sequence level is an address in EEPROM of how many LEDs are displayed, and I add an offset into that of the actual level itself, and then I read the EEPROM address. So I'm just going to quickly go down to that part of memory which is right at the end. So here's the LED sequence level, and so if the offset is 0, which will be level 1, it just displays 1 LED. If the offset's 2, then it displays 2 LEDs, and so on, 3 LEDs and 4 LEDs for level 4. And because I've also added this flag here, sequence pause, it means it won't animate. Even though this is an animation definition, I've added a flag to say don't animate this, so when you display level 1, it just displays 1 LED for the period that it's displayed for. So I'm going to try and find my place again back up at the top. Okay, so we've just read the EEPROM for the LEDs, and it just moves that into LED state. So it's not animating anything, it's just going to set the LED state to the number of LEDs for the level, and then it's going to play a tune as well. So in the tune level lookup, so there's a lookup tables for the tune that you need for a particular level. So this is very similar, and it adds the offset of the level to that lookup table. It then reads what the actual tune location is and puts that into the tune pointer, and at that point it'll start playing the tune for that level. So I'll just flash down again to the bottom where the EEPROM definitions are, and here is the tune lookup table, and so this would be the first level, then it adds offsets for level 2, 3 and 4, and that just defines which of these tunes it needs to play for each particular level, and all they are is either play 1 beep or 2 beeps for level 2, or 3 beeps for level 3, or 4 beeps for level 4. So going back up again. Okay, so that was a tune level lookup and read the EEPROM. Okay, so after it's started playing whichever tune it needs to play, it's going to do a short pause. So this is because if it didn't do a pause, then the processor would just carry on and do the next thing, and the user wouldn't get a chance to see the level on the LEDs that have been displayed. And by calling pause, it will just display those LEDs and make them play the tune for the level as well. So then it just goes on to check for the next key press. So this is to see if the simultaneous LED level key has been pressed, and if at any time it doesn't detect one of those key presses, it just falls through to the next key press just to check that. But if this key press has been pressed, it's very similar to the previous key press. So setting the level and the simultaneous level is pretty much identical, really, apart from you don't need to set the number of sequence counts for this. So it loads 4 to see, so the level can only be from 0 to 3, so if it gets to 4 it needs to wrap back to 0 again. So it does an exclusive OR to just with the actual target value of 4 to see if it's reached that, and if it has reached that, then it will set simultaneous back to 0 again. and then it does the same thing for displaying the LED of the sequence levels that have been selected, and it adds the offset, reads the LED value that needs to be displayed, and then displays the LED value, same as above. And the same for the tune. It looks up the tune level table, it adds a simultaneous offset, reads the tune pointer that needs to be played, adds it to the tune pointer, which starts playing it immediately, and then it does a short pause again just to allow the user to see the simultaneous LED level which has been selected. So the next key press to be checked is if the sound is to be toggled on and off. So by default, when the battery is put in and it initializes, the sound's off, but the first press of this key will toggle the sound on, the next press will toggle it off, and then on and off again. So what it'll do is it'll just light the LED for the sound button, so that the user can get feedback that okay, it's recognized that they've pressed the sound button. It just lights that particular LED. And it checks to see if the sound is currently on or off, because it's going to toggle it the opposite way. So it'll go to switch sound on if it's currently off, and it sets a flag in the application flag to say to the application sound is on, and then the application can check this flag and play sound if it sees it switched on. And when it turns the sound on, it also plays a tune to say that the sound's been turned on, and moving that into the tune pointer will start that playing straight away, and then it'll do a pause again just to show the user what's happened. However, if the going back up here, if the sound was on, it needs to then turn the flag off. So if it'll clear the flag for the sound, and it'll turn the sound off if it was previously on, and it'll skip down to this sound pause thing, and it just does the short pause. So, but it will light the LED, but it won't play any music, and that's just to show that sound's off. So it'll light the LED in silence, and then just do a quick pause. And then the last thing that the user can do is it checks to see if the start game button switch has been pressed, and if it has, all it needs to do is set the next mode to game mode. It just calls set mode, and then after all of the keys have been checked for, it clears the key press flags, because next time it comes around this loop, it doesn't want to process the same keys again, so it wants all new keys if any keys have been pressed. So it's important to clear the key presses after you've processed all of the key presses. And that's the end of this particular section. So that handles all of the user interactions for setting the options for the game. And then the final bit of the game left is to actually play the game, which is down here. I put like a dummy function in just at the minute to clear key presses, so that if someone does go into game mode in this little demonstration, it will allow the device to sleep after a timeout period. So the code for this part has been programmed onto this PIC device, and when I put it into the circuit, so it starts animating, and I can select the level using the first button. If I turn the sound on, it turns on, and I can select the sequence level with the second button. It wraps back around to 1 again. Or I can start a game with the fourth button, but that doesn't do anything yet because I've just got the dummy function in. And when it's in game mode, all the other buttons don't do stuff because it's in game mode. But if you let it go to sleep, when it wakes up from sleep, the default mode is going back to the settings mode. So I'll just let it sleep. And then when I press a key, that'll be back in settings mode. So the first time you press a key, it wakes up the device, and then we're in settings mode again, can turn the sound off. It's in silent.